Good morning. I am Dr. Alok Agrawal and I invite you on the next lecture of our subject that is internal combustion engine. Today's topic is valve timing diagram. So in this lecture, what we will study? We will study about ideal valve timing diagram and the factor affecting ideal valve timing diagram. We'll discuss these two topics in detail in our today's class. So first of all, what is valve timing? Valve timing is the regulation of the points in the cycle at which the valves are set to open or close. If we'll say this in a very simple language, valve timing decides when the inlet valve is open or closed, or when the outlet valve is open and closed during the operation, during the cycle of operation, during the 720 degree of crankshaft revolution, or during the four stroke of piston. At what time the inlet valve is open and at what time the inlet valve is closed. Similar is the for exhaust valve, at what time it opens and at what time it closes. The timing of those things is called valve timing. Now, ideal valve timing diagram. What is ideal valve timing diagram? The valve timing works according to the ideal cycle that we have seen, that is Otto cycle and diesel cycle, and the diagram plotted on the basis of ideal cycle is called ideal valve timing diagram. Means it considered that the inlet and exhaust valves are open or closed at dead centers only. Means when the piston reaches top dead center or when the piston reaches bottom dead center, at that time only the inlet valve is closed and inlet valve is open. Similarly, exhaust valve is closed or exhaust valve is open. The diagram plotted on the basis of that are called ideal valve timing diagram. Let us see what is ideal valve timing diagram looks like. Okay, so this is top dead center and this is bottom dead center. Suppose this is 0 degree, this is 180 degree, this is complete 360 degree. Okay, so when we start the cycle starts when the piston is at the top dead center. So at top dead center, when piston starts to move down to complete its suction stroke, or we can say that when suction stroke starts, inlet valve will open. So this is the point. So this is the point where the inlet valve is open when piston is at the top dead center. This IVO represent inlet valve open. Okay, so inlet valve open at TDC at the start of suction stroke according to ideal cycle. It will remain open till the piston reaches bottom dead center where the inlet valve close, that is IVC, inlet valve close. So according to ideal condition, what is happening? Inlet valve starts open at at the start of suction stroke when the piston is at top dead center, and the inlet valve closes exactly when the piston reaches bottom dead center, or we can call it as the end of suction stroke. So during the 180 degree of revolution of crankshaft or one stroke of piston, inlet valve remain closed and outlet valve remain inlet valve remain open and outlet valve remain closed. Once the piston reaches bottom dead center, suddenly inlet valve should close, and during the compression stroke both the valve will close. During the expansion stroke again both the valve will close, and when there is a start of exhaust stroke, when piston is at bottom dead center after completing the power stroke, exhaust valve open. So here you can see that EVO, exhaust valve, is open at the end of at the start of exhaust stroke where the power stroke just end at bottom dead center. So what is happening? Exhaust valve should open when the piston reaches bottom dead center after completing power stroke, and it is going to start the final stroke, that is exhaust stroke, and the exhaust valve remains open till the piston reaches top dead center and exhaust stroke end. So this is called ideal valve timing diagram. Here again, fuel injection occur at top dead center when piston completed its compression stroke. Fuel injection spark ignition occur at that point only. Ignition start at that point only. Okay, or in case of SI engine, it is that is a spark. And in case of fuel injection, it is fuel injector. Okay, so this is how ideal valve timing diagram look alike. But it is not the actual case because there are other factors because of which the actual valve timing diagram cannot be same as that of ideal valve timing diagram. In actual, inlet and exhaust valve does not open and close at dead center. एक्चुअली क्या होता है कि जो इनलेट और एग्जॉस्ट वाल्व है वो डेड सेंटर में ओपन या क्लोज नहीं होते हैं, या तो पहले ओपन होते हैं या बाद में क्लोज होते हैं. तो जो दो फैक्टर, the two factors which govern the actual valve timing diagram and make it different from ideal valve timing diagram are, first one is mechanical factor. Now, and second one is dynamic factor that we will also discuss. But first of all, see what is mechanical factor. Because of this factor, we cannot make that inlet valve is open at top dead center and closes at bottom dead center. Similarly, exhaust valve is open at bottom dead center and closes at top dead center. It is because we have seen that the inlet and outlet valve is operated with the help of cam mechanism. Okay, and this is a mechanical component. So operation of that mechanism will take some time, will require some time. It cannot be an instantaneous process. If you want to make it instantaneous, then we have to make it fast, and because of that there may be noise and wear as well. So it cannot be an instantaneous process. We cannot close or open any valve abruptly because it is operated by crankshaft revolution and cam mechanism. Also, because of some clearance between the cam and all mechanism, it has to be some delay in that operation. So it is because it is a mechanical process. Mechanical factors govern the valve timing diagram. Now see how it is happening. If valve has to be open completely at the suction stroke, then we have to start the opening of inlet valve before reaching piston to the top dead center. It means जब पिस्टन टॉप डेड सेंटर में पहुंचने वाला है उससे पहले ही हमको स्टार्ट कर देना पड़ेगा प्रोसेस इनलेट वाल्व ओपन करने का. अदरवाइज व्हाट विल हैपन at the time of suction stroke, when piston move from top dead center to bottom dead center, it may be possibility that the valve is not open properly, and because of that, less amount of air and fuel mixture will inducted into the chamber. So because of this mechanical factor, we have to make the valve open well before top dead center. Similarly, we cannot close the inlet valve at the bottom dead center because again it will take some time, and because of the inertia of the fluid we want that maximum amount of air and fuel will be inducted into the combustion chamber so that maximum amount of power is produced. So we will close inlet valve after BDC because because to allow large amount of fuel and air mixture to get inside it. So this is mechanical factor because of which we cannot make inlet valve open at TDC and exhaust valve is open at BDC. We have to make exhaust valve open we have to start exhaust valve opening before piston reaches BDC so that at BDC the exhaust valve will be completely open, and when piston start moving from BDC to TDC there will not be any hindrance for exhaust gases to go outside the engine, and less power will be required at that time to make vacant the combustion chamber through exhaust gases. Okay, so these are the mechanical factors because of which inlet valve should open before piston reaches top dead center, and exhaust valve should start opening before piston reaches bottom dead center. Another factor is dynamic factor which govern the valve mechanism because when the fuel air mixture or air will coming from inlet valve, it has certain momentum. Okay, what we want that maximum quantity of the charge get inducted into the combustion chamber to get maximum power out. जितना ज़्यादा चार्ज आएगा उतना ज़्यादा पावर आउटपुट हमको मिलेगा. तो we cannot abruptly close the inlet valve when piston reaches bottom dead center because there is a momentum of fluid which is coming inside the combustion chamber. That's why we make some delay in closing the inlet valve during suction stroke, and inlet valve will close after piston reaches BDC after some degree of length of revolution, so that maximum amount of charge will be get inducted into the combustion chamber. Okay. Similar is the case when exhaust stroke is happening. We cannot close the exhaust valve when piston reaches top dead center. We will make some delay in closing the exhaust port, exhaust valve, so that maximum amount of burned gases will go out of the combustion chamber, so that there is enough space for fresh charge to get inside the combustion chamber. Okay, so this is the dynamic factor because of which we cannot close inlet valve just at BDC. We have to make it uh, inlet. We have to make inlet valve open after when piston reaches BDC. After some time, we close inlet valve so that maximum quantity of air gets inducted. Similarly, we cannot close exhaust valve at BDC. We will close it after some degree of revolution when piston reaches BDC so that maximum quantity of exhaust gas will inducted, sorry, taken out from the combustion chamber for making space for fresh charge. These are the two factors because of which actual valve timing diagram will be different from ideal valve timing diagram. So on the basis of these two factors, we will study in our next class what will be the actual valve timing diagram of the engine. Okay, so for today's class, this is enough, and we'll in next class we will see the actual valve timing diagram of SI and CI engine. Thank you.